Chromatography is a collective term for a set of lab techniques that involve a separation of mixtures based on their polarities.
Okay, you want to start by drawing a line 1 centimeter from the bottom. Space the dots evenly across the line drawn at the bottom of the plate.
And this is our unknown.
No, wait.
Oh, okay.
It says, so you can now
which one I used, I just don't remember.
There you go.
A specific name.
Alright, so then you take the TLC plate and you put it in the beaker, in a beaker large enough so that the edges don't curl. And you add a thin layer of solvent, just enough so that it's below the baseline drawn with the pencil. And then you cover it with plastic wrap and wait for the solvent to rise, and the dyes will rise along with it.
We're going to measure the distance between the pencil line that we made earlier and the line where the solvent stops. Ours is 4 centimeters. Then we're going to record the distance that each different dye traveled. We're going to measure to the middle of the dot. So for our first dye, which is methyl red, it is 2.7 centimeters. On our TLC plate, for the first dye and the unknown dye, we have 2 different colors separating. So we have 2 different measurements for each of those. So we recorded both for those 2, but all the other dyes only had 1 measurement. To find the RF factor, you divide the distance traveled by the dot over the distance traveled by the solvent. So for our third dye, the dot traveled 3.1 centimeters over the 4 centimeters that the solvent traveled.
These are our values for the RF. The mobile phase is the solvent, and the TLC plate is the stationary phase.
So the reason that the dyes move like different lengths up the TLC plate is because of their polarity. So the TLC plate is nonpolar, the stationary phase, and the mobile phase, the solvent, is very polar. So as the solvent is moving up the TLC plate, the dyes that are more polar are going to follow the mobile phase or the solvent, and so they're going to move farther up the TLC plate because polar dissolves polar, like dissolves like. And the dyes that stay closer to the baseline are the non-polar or less polar dyes, because they don't follow the mobile phase. And the ones that are in the middle are the ones that are not as polar. They're still somewhat polar, but not as polar as the ones that are the dyes that moved highest up on the TLC plate.